So when we talk about restrictions on the domain, so if we have a question like here, find a suitable domain for this function. So this f of x is equal to 7 over x minus 2. So basically what we're saying is what numbers can and can't x be really. So for this one here, what we're going to think about is well, you see this x at the bottom. Whatever happens, we can't have this bottom part equal to 0. So it's not possible to divide by 0. So we say that the domain must exclude the numbers that would give 0 in the denominator. So you can have something like, we'd have to do an equation like this. Okay, well, the bottom can't be 0. So x minus 2 cannot equal 0, right? So therefore, x cannot equal 2. Okay? And what about for this one over here? Well, again, the denominator cannot be 0. So you'd have something like x squared plus 2x minus 15 cannot equal 0. Then we factorize this. Well, 15 and 2, so 3 and 5. And there's a difference of 2 there. So we have x plus 5 x, so we're going to plot plus 2, so negative 3 cannot equal 0, right? Therefore, x cannot equal negative 5, and x cannot equal positive 3. Because if you put either of these numbers in, what's going to happen is the bottom's going to equal 0, and then the function won't work, basically. So you write a statement like this saying x is going to be a set of real numbers where x cannot be equal to negative 5 or 3. And then you can do the same for this one over here, which should be x is a set of real numbers where x cannot be equal to 2. So that would be your statements that you wanted to make there. But what about other scenarios, other restrictions on the domain that you might have? So again, we're asked here to find a suitable domain for f of x where it's equal to the square root of 3x plus 2, and here we have x squared minus 5 minus 1. So again, what are the rules for square roots is you can't have the square root of a negative. So, it's not possible to take the square root of a negative number. Therefore, the domain must exclude the numbers that would give a negative number. So therefore, you could think, negative numbers are illegal, or not even that they're illegal, they just wouldn't work. So again, we're going to do a similar thing to before, where instead of using can't be equal to, we're going to use greater than. So here, we're going to have 3x plus 2 has got to be greater than or equal to 0 for it to work. So 3x must be greater or equal to negative 2. So x must be greater or equal than negative 2 over 3. And you want to write your set, which is x is a set of real numbers where x has to be greater than or equal to negative 2 over 3. And I'm going to do the same thing over here. So you have x squared minus 5x minus 1 is going to be greater than, or so I got that the wrong way around, has to be greater than or equal to 0. So then we have to factorize this, which is going to be what adds up. I think, oh, one sec, I think this has been typed in incorrectly. This should be 14. Yeah, otherwise it wouldn't work because this doesn't factorize. 14. So what multiplies together to make 14? Well, 2 and 7 do. And the difference between them, so if we have minus 7 plus 2, yeah. So you'd have x minus 7 and x plus 2 have got to be greater than or equal to 0. So x must be greater than or equal to 7, or x must be less than or equal to -2. Okay, so sometimes that goes, okay, well, that's a bit confusing. How can I visualize this? Okay, well, if you just draw a graph, and you think about this expression here, x squared minus 5x plus 14. When we get these here, we get the roots here. We're seeing there's a root at 7 and there's a root at -2. Okay, so, and we know it's a positive polynomial, or so so this is going to have a minimum point, or smiley face. So there's going to be a point at -2 and there's going to be a point at 7, right? And what the question's asking us is, when is this expression greater than 0? Well, it's going to be greater than 0 when x is bigger than 7. So for all these values here, it's positive, 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 positive. And for all the values less than -2, it's going to be positive. But all the values in between, they're going to be negative. Okay? So this is quite often an exam question, and often it helps to draw a bit of a sketch. So what would this look like in writing out the set notation? So x is a member of a set of real numbers where x has got to be less than or equal to -2, or x has to be greater than 7. Okay.